Welcome everybody. My name is Germano Franzoni. I'm a senior system engineer working for Parker Hannifin in the global system engineering team. I'm also a business development manager for several markets, one of them being the truck refuse industry. Today I want to give you a brief presentation on an overview on electrification in the refuse truck industry. I will try to keep this seminar pretty short, around 15 minutes maximum, so everybody can enjoy it without wasting too much time. So I will go through an introduction, and then we're going to talk about the overlook of the full electric refuse truck and the challenges that OEMs and bodybuilder face when they want to convert an engine truck to a fully electric. And these challenges, most of the challenges evolve around the ePTO. Finally, we're going to look also at a hybrid, which can be a potential alternative also based on some recent development. And we'll study a very simple layout that we have developed here at Parker Hannifin, and we're going to go through the conclusions. So, as many of you know, there is a bunch of drivers which consist in emission regulation, environmental concern, corporate initiatives, and especially government incentive that basically are bringing many OEMs towards the development of fully electric solutions in several markets. And especially the refuse truck market has seen, as you can see in the last or also the previous year Waste Expo, all the major OEMs are actually showcasing fully electric vehicles. The truck manufacturer, the truck OEMs, also the chassis OEMs, sorry, they also have futuristic projections in which they think that electric batteries and fuel cells trucks are going to cover by 2050 more than 50% of the population. So, what are the components of an electric truck? So when we talk about a refuse truck, as for an engine truck, the refuse truck is the electric truck is defined by two main elements: the chassis, which in this case is a fully electric chassis. So it has an electric transmission, it has batteries to power the vehicle, and also it has a battery management system and cooling for the electrical units. So these are the key elements of the chassis and the differences with respect to a traditional engine chassis. Well, the chassis, as for every truck, has to be matched with a body, and the body contains basically the different hydraulic and mechanical functions to collect and compact the garbage. So ideally, every OEM wants to maintain the same design, so we don't want to change cylinders, we don't want to change geometry of the compactor when it comes to an electric refuse truck. But the big question is, in a traditional engine truck, we have a system which takes off, actually it's called the power takeoff, that takes off power from the main transmission of the truck and is used to provide hydraulic power to the body functions. How do we achieve the same functionality in an electric truck? Because in an electric truck, we don't have the same type of transmission and we don't have the same opportunity of pulling out power from the transmission or the driveline. So in this case, the answer is called ePTO. So what's the ePTO that we find on electric trucks? In a few words, the ePTO is basically an electro-hydraulic power unit which is supplied by the chassis batteries and creates power for the body hydraulic function. So basically the ePTO is the linkage between the chassis, because it's supplied by the batteries on the chassis, and the body, because that's where the hydraulic functions are powered by the power unit, by the ePTO itself. And if we look at the possibilities that the different refuse OEM have, they can stick to two options. Option number one is to basically use an ePTO which is provided with the chassis. So the chassis supplier, some chassis suppliers can provide an ePTO, which is just an electric motor to which we can attach our pumps used to drive the body function. In alternative, we have seen also bodybuilders who actually want to develop their own ePTO. So instead of relying on the chassis supplier, they want to develop their own ePTO and integrate it with the body. So what's the difference between these two solutions? If you look at a chassis supplier provided ePTO, well, the ePTO provided by the chassis supplier never includes hydraulics. So the ePTO is just an electric motor with an inverter and a pump mounting pad. Of course, having the ePTO to serve multiple potential applications of the chassis, the mounting and control options that this ePTO provides are often limited based on what the chassis supplier wants to define in their design. And also this creates an issue, a potential limitation for the bodybuilders, and it's a big challenge because, as you all know, different customer, different collection company require the use of different chassis. So some are more used to Mack, some are more used to Peterbilt, some are more used to Autocar, and every chassis supplier is going to have different concept in the ePTO. So maybe different mounting option, different power requirement, different control option. And so in that way, this creates a challenge for the bodybuilder because the bodybuilder has basically to create a system that adapts even more to different chassis. So the challenge of having different chassis using the same body is even brought to the next level here on the electrical domain. That's why we have seen many bodybuilders deciding to take a different route and opting for a chassis that doesn't have any ePTO and develop their own ePTO solution. In that case, if the bodybuilder develops their own PTO, their own ePTO can be an optimized design for the specific system that they want to use in their application, being a front, a rear, or a side loader, and also the control options, the controls, so different torque or speed controls that you can embed in the inverter and the motor of the ePTO can be optimized for the type of application or the type of their own system. Second, the possibility of selecting their own motor, inverter, and pump allows them to tune them together for the specific application, and this leads to the maximum efficiency of the system, because when it comes to battery, the efficiency of the system becomes critical in determining the life of the battery and how much runtime the truck can have. And last but not least, if the bodybuilder owns the ePTO design, then the same ePTO can be mounted on different chassis. And so in that case, the challenge of having different potential chassis for the same body has basically simplified by owning the bodybuilder, by having the bodybuilder own the design of the ePTO. So in this slide, we see, for example, a typical ePTO that has been developed by a bodybuilder using Parker components in this case, and it basically it is made of an inverter. We see it on the left side, the inverter, and so on the left side we see the inverter is this box that basically controls the current and varies the frequency of the current to the motor, so basically actually controls the speed and the torque of the motor. And this is coupled in this case with a variable displacement piston pump, and the ePTO includes also a frame that is mounted to the truck, and also, last but not least, it includes the cooling system. In this case, is not seen, but behind this wall there is a coolant pump that basically uses the coolant from the chassis to basically maintain the inverter and the motor at the perfect temperature. So designing such a complex system, you can see from this picture that designing such a complex system is a pretty complex challenge, and also the knowledge to design this type of system usually goes beyond the traditional knowledge of bodybuilder that bodybuilders have developed during the years. So as we said, it's a complex design. It's a complex design for basically three reasons. The first reason is the thermal management, because usually inverter and motor like to run at different temperatures. So the challenge is that to create a thermal management system that maintains the inverter and the motor at their independent optimal temperature. Second, the inverter and the motor needs to be tuned together. So the parameters for controlling the inverter and the motor have to be matched, and they also have to be optimized for the specific application, so the specific speed and torque that the application is requiring. As the motor has to be paired with the inverter, the pump is also another element that needs to be paired with the motor and the inverter. Because, for example, in this case, we represent a variable displacement piston pump, because the possibility of combining a variable displacement pump together with a variable speed motor gives you a lot of potential saving in terms of efficiency, because you can always, for example, optimize the speed and displacement combination to obtain the right amount of flow that your application is demanding. So how do we design an ePTO? So what are the rules, the guidelines that the OEMs, the bodybuilders should follow when they want to design their own ePTO? So first of all, I think it's necessary to overlook at the truck as a whole system and revisit the hydraulic system for efficiency gains. So for example, in traditional engine driven applications, the efficiency is not as critical, because a full tank of gas can allow the truck to run for several days, several hours. Now, when it comes to battery management, the runtime of the battery becomes really critical. So maybe where we are having, for example, a single pump system, so a system where a pump is providing flow and pressure to the body function and the packing function, now maybe just splitting this pump into two separate pumps, one providing flow to one group of function, the other one providing flow to a different group of function, can lead to several savings. So first of all, one OEM can decide to keep the hydraulics the same, so the layout the same, or another OEM can actually slightly revisit the hydraulic system to optimize the efficiency. The second challenge lays in the thermal management. Why? Because there are two challenges. One of the challenge is basically, as I said before, maintaining the inverter and the motor at different temperature, at their optimal temperature, which are not always the same. And second is, how do we interact with the thermal management system of the chassis? Because we have to pull water glycol from a circuit that is already existing on the chassis, or do we want to create our own independent circuit with another heat exchanger? Third is, how do we interact with the batteries? So what type of batteries are there on the chassis? What type of voltage? But not only, how is the BMS managing the batteries? Does the BMS allow any, what's the amperage draw that is allowed? So there are things to be considered also in how the ePTO interacts with the batteries. The motor, when you size the motor, you have to be really careful at understanding what's the continuous or the intermittent torque, because the motors that are using this type of application are usually synchronous permanent magnet motors, and these motors change very much the requirement, change very much the performance if you are in the continuous or in the intermittent domain. So clearly analyzing the duty cycle and the way the motor is used can allow us to decide how much of the work is done in the continuous and how much of the work is done in the intermittent domain, and coming to a sizing of the motor that is actually much smaller than a lot of times is the result of just a continuous sizing. The same thing is for the inverter. Inverter needs to be sized properly, and especially the inverter needs to be matched to the motor, because different motors require different tuning with the same inverter. So how do we tune the motor and inverter together, but also how do we control the speed and torque of the, how do we limit the power, how do we limit the amp draw from the main battery? And also, if we want to run above the flux weakening area, how do we optimize the controls of the flux weakening area? Safety is critical because when we deal with high voltage systems, it's very important to have a system that is intrinsically safe. So for example, active discharge, safe torque, or compliance with the proper ISO standards. Last but not least is the packaging, because isolation and vibration dampening are critical for the proper operation and the life of an ePTO. So let's take, for example, a side loader. When, as I mentioned before, when OEM wants to build a ePTO for a side loader, it has a lot of options, also starting from the way the hydraulic system has to interact with the ePTO. So this is the traditional system that equips a lot of side loader, where a single pump that can actually be fixed or variable is actually supplying flow in parallel to the arm valve or the pecker valve. This is the traditional system that is present on engine trucks. However, when we go to electric truck, one can decide to keep the same economical system, or can maybe try to increase the efficiency of the circuit. So for example, in the second option, the efficiency of the circuit, and so the life of the battery, can be increased by just splitting the main pump into two separate pumps, where one provides flow to the arm valve and it goes power beyond to the pecker valve, and the second pump is dedicated to the pecker valve. So in that case, we split the two circuits, there is less pressure interference, less overproduction of flow and pressure, and the efficiency of the system is significantly increased. Or one can take it even to the next level, where now the two pumps are not only, the pump is not only separated in two single pumps, but the two pumps are actually driven by two separate motors. In this case, it's possible even more to optimize the efficiency of the system, of course, increasing the complexity, slight increase in the complexity, but also gaining in terms of efficiency and battery life. So at the end, the decision is always what's the impact, is driven by what's the impact on the cost of ownership of the vehicle, where the vehicle includes basically all the components of the body and the chassis. So when it comes to the ePTO, we think at Parker Hannifin that the ePTO is the challenge for bodybuilder, is the biggest challenge right now for bodybuilders that want to make electric trucks, and it's also the ideal partnership opportunity for a company like Parker, because we have both the product and the expertise to help the OEM develop their own ePTO. And we actually are working on two separate parallel paths. The path of a modular design, where basically the ePTO, the bodybuilder is in charge of the frame, of locating the different components into the frame. It's basically a more flexible, more customizable solution, more scalable, but it's less integrated than the second option, which is the one on the right, in which our Chelsea division is working towards a single, fully integrated system, plug and play, that can actually be bolted on the side of the truck. The nice advantage of this system is that it integrates the internals of our GVM motors, which are permanent magnet synchronous motor, the internals of our GVI inverter in a single housing, in a single casting, and also it uses a spur gear to basically reduce the speed of the pump versus the speed of the motor. This basically allows the motor not to drive directly the pump shaft, but to drive the pump shaft through a gearbox, and the gearbox allows basically the motor to run at 4 times higher speed rather than the pump speed, so the motor goes actually to run into their optimal speed range. So now the question is fully electric the only solution for a battery for an electric vehicle. Right now the incentives are only focused towards full electric vehicles. That's why everybody is focusing on that. However, the batteries have a high cost and a high weight impact, and the cities want more electric equipment, but fully electric vehicles cannot be the only solution. Maybe some cities want some sort of electric in their vehicles, but also are open to other solutions like hybrid. So basically, we think that hybrid can represent a solution because it's simpler, it's lower cost, it provides very good advantages for the end users, and it still reaches the green sticker status. Plus also, we have seen, as I say here, that basically we have seen some municipalities or some cities giving away incentive and rebates also for hybrid, not only for fully electric vehicles. So in this case, Parker has developed an electric hybrid which is focused on the implements of the truck. So the chassis of the truck remains an engine chassis driven by an engine, a traditional engine chassis. Right now, instead of driving the pump directly from the ePTO, our engine through the PTO drives the pump, and behind the pump we can place an electric motor. In this case, our electric motor can act basically as a buffer where we can either store energy into a small battery or reuse the energy to power the pump. Of course, the motor is driven by an inverter, and here we have the batteries, which are not the chassis battery, because right now the chassis is a traditional engine chassis, but it's a small battery pack that is equipped on the body. How does this system work? The system is very simple. The PTO has a clutch. So if the clutch is engaged, the pump is active, and the motor is freewheeling, then we have a traditional system where the engine is driving the pump and the motor is just there to speed and doesn't provide any resistance. However, if the demand of power to the chassis is low, we can have the pump either active or standby, and the motor can pull also energy and charge the battery. So in this case, the motor works as generator. During high demanding phases of the cycle, the electric motor can actually invert the operation, and from a generator charging the battery can turn into a motor, adding power on the shaft, and so driving the pump and helping the engine to drive the pump. We also have the option to completely disengage the PTO, and in that case, the truck engine can even turn off, and now the pump is actually purely driven by the motor. In this case, our truck is an engine off truck working in electric mode. So this is a brief overview of the hydraulic circuit that can be implemented for a hybrid truck. So we have the PTO, which can be disengaged and run completely in electric mode. And for the compaction, we can have hybrid mode while driving, while also recharging the battery. And what are the benefits of this system? The benefits is, first of all, we have noise and emission reduction, because we have the opportunity to reach the can, turn off the engine, grab the can on fully electric mode, and restart the engine and go to the next house. And second, we know that most of the operation of a side loader is done at idle. And idle is the point of the engine operation where the efficiency is definitely the worst. That means a lot of fuel consumed and a lot of emissions put into the atmosphere. So having the possibility of running the can pickup and compaction from a fully electric mode allows to reduce significantly the emissions of the truck. Last but not least, we have the possibility of running the pump in electric mode always at the optimal temperature. So in this case, at the optimal speed, sorry. What happens is one of the challenges of traditional engine trucks is that the truck is run mostly at idle, and so the pumps, they run at a relatively low speed, and so they need to actually be oversized for the application. So the installed power on most of the side loader is actually much higher than the actual power used by the pumps. In this case, when we run the pump in full electric mode, we can actually optimize the speed, so we can actually increase the speed significantly and downsize the pump. Last but not least, the battery that we use as a buffer has not to be thought as a large battery like, for example, on an electric chassis, but the battery becomes pretty small and is just a buffer. So in this case, we were running a 10 kilowatt-hour battery, which is basically the weight of 210 pounds, which is basically working as a buffer for the truck. So in conclusion, the migration towards electric refuse truck has started and it cannot be reversed. However, this development of new solutions for electric trucks includes a bunch of challenges for the OEMs and also a bunch of opportunities for companies like Parker Hannifin to partner with the OEMs, with the bodybuilder, to develop the best solution for the application. When we talk about an electric refuse truck, the ePTO is definitely the key element and is the element that provides power to the body function. So the biggest challenge for the bodybuilder is to select and design the proper ePTO solution for their application. And we have seen that there are two options. Option one is probably the simplest option for the bodybuilder, is to just mount a pump, one or more pumps on the chassis provided ePTO. This is, of course, the easiest option, but the advantages are limited because it doesn't allow the OEM to take full advantage of the capability of the ePTO solution, of the motor, the inverter, and so it doesn't allow the OEM to optimize the design of the ePTO for the battery use. On the other hand, the bodybuilder can develop their own custom ePTO. Developing their own custom ePTO lays several advantages. First of all is the optimization of the ePTO for their application. The ePTO can be used with multiple chassis, and the ePTO can actually be optimized for maximum efficiency. Finally, we have seen a couple of slides on a hybrid solution. We think that hybrid, even if it hasn't been very popular lately, driven mostly by the incentive which are geared towards full electric solution, we think that hybrid still has a potential because hybrid can be a simple solution to achieve electric functionality and noise and emission reduction. And last but not least, we have seen some incentive now being open also for hybrid solution. With this slide, I finish my webinar. I hope the information that I provided was helpful. If you need any question, you can contact Parker Hannifin.